This is video 31 on MicroPython on LVGL 9 on a Raspberry Pi Pico. In this video, we begin using a larger display. We research 2 available displays at our online retailer. We will choose a display and walk through the driver considerations. Finally, we will test the display with 3 different LVGL programs. For this effort, I continue to use the Pico MicroPython display baseboard with the Pico2 USB board and a display with XPT2046 touch. The GitHub site contains the firmware for the Pico, PicoW, and Pico2, and the MicroPython code files relevant to this video. As this channel covers multiple small system solutions over time, please subscribe to stay informed and click like, as that really helps. I am running the program Test Matrix Display in Thonny. This program contains 54 button widgets distributed evenly throughout the display. Each button's clicked event is connected to a callback routine that prints the button's labeled text to the Thonny shell. I'll show that by clicking on a few buttons. Alright, we'll click on 2.10.4, 10.6, 410.1, 410.6, and 10.1. Besides being colorful, the program helps you verify that the touch display is in sync with the widgets. Okay, let's look at the research. Going to my favorite online retailer, I did a search on 480 by 320 displays. They were basically 2 choices, the Ili9341 and the ST7796. As I looked at the information, I found 2 specific displays that had the same mail headers as my smaller Ili9341 displays. Next, I checked the LVGL online documentation. I found that the site specifically mentions the ST7796S display. I reasoned that this should make it easier to transition to a larger display. Here's the display I found on my retailer's online site. Here is a close-up of the display. It's good that the mail headers are the same as the Ili9341 display. In fact, I just pulled out the old display from the breadboard and pushed in the new display on my test bed. Here's a close-up of the mail headers. Now let's look at a view of the wiring. Notice that the touch and display both use the same SPI 0 port pins on the Pico or Pico2. We will allow the software to manage the SPI use. Also, we are just using the 3v3 out pin to power the board. Here's a picture of my rig holding the baseboard and display. I used the demo program to show off the colors and size of the display. Okay, well, what are the driver considerations? Well, there are 3 considerations. First, we need to update any hard-coded 240 by 320 resolutions in the display driver and its child, the Ili9xxx.py program, with values for the larger 320 by 480. 2, we need to add the ST7796S screen initialization commands to the Ili9xxx.py driver file. And finally, 3, we need to update the touch driver file to the new resolution. We will do that by creating the file XPT2046_B with the larger resolution. And to keep things simple, we will continue to use landscape mode with the default rotation. Let's discuss the changes to the file Ili9xxx. Currently, it contains the Ili9341 driver settings in 3 sections: a hardware address constants area, a class called Ili9341_HW, and a class called Ili9341. The class Ili9341 is the class that is used in our display driver file. and it calls the class Ili9341_HW. This hardware class has three routines. First, the init routine has the hard-coded screen resolution. Second, the config_HW performs the display initialization using the hardware address constants we talked about earlier. And thirdly, there's a routine to perform the display rotation. Well, fortunately, the ST7796 display uses the same hardware address constants as the Ili9341, but of course it has different values. What I did to update the display drivers was I copied the Ili9341 routines and renamed them to ST7796 at the bottom of the Ili9XXX program. I changed the init to use the larger resolution, and since the Pico or even the Pico2 has limited memory, I changed the factor to 8. A larger factor means a smaller screen buffer which accommodates the increased pixel resolution of the larger display, and it fits all in the Pico's memory. However, this means it takes double the time to load a screen. Fortunately, the ST7796 is fast, and we can more than triple the speed of the SPI, and so it actually displays faster. This gave me a working display. The driver files on the Pico should look like this. Let's walk through the three files to see what changes I made. First, the XPT2046_B file. As we scroll down through it, we'll see line 52. And on line 52, we've defined the width as 320 and the height as 480. Because of this, I gave the file a different file name _B, although you could just edit your original XPT file. But that's the only change needed in this file. The next file is the Ili9XXX file. Let's look at it. This is the file that has the driver hardware address constants and definition for the Ili9341. What we did is we copied everything of the Ili9341 and put it at the bottom of this file, naming it ST7796, so it's very similar. You have the same three functions. However, in the hardware routine, we're going to use 320 by 480. When we call it, initially, we're going to use a factor of 8. Finally, the configuration hardware is very similar to the 9341. The only difference is we have different gamma settings. Now let's look at the display driver. The display driver needs to call the new XPT2046_B driver routine. Again, you could just edit the original one and wouldn't have to change it, but this way you can go back and forth between a small display and this larger display without having to remember to edit it every single time. Notice that we've increased the speed of the SPI from 20 to 60 megahertz. We now have a definition for the ST7796, so we just comment out the 9341 and put in the ST7796. I've set its rotation equal to 0 because my display likes it that way. We set the screen resolution to 320 by 480. And here, when I create the display, I want to do the opposite. I want the 480 as the width and the 320 as the height. So that's the display. Remember, the rotation is 0. and the touch rotation is 0. Then down in the callback for the touch, I've modified the XY values because for my display I needed to change the coordinates in this manner. Also, instead of using the scale value routine that we had previously, KD Schlosser mentioned in a forum discussion that this is the better way to calculate Y. Notice here the coordinates are Y comma X. So this orientation of the XY accommodates my screen in landscape mode. And that's it. Okay, let's look at a couple example programs. The first program we're going to look at is the chart display that used in the ULab program. Okay, this is the test chart ULab program, but I've modified it. You'll see that when we click the update, it updates very nicely. The biggest thing I've done is I made the screen dimensions for the chart area much larger. I moved the update button and I corrected the X range on the axis on the chart. Let's reset it. Okay, this is the test keyboard display program we had from 4 or 5 videos back. And the first thing we notice about this program is that the LVGL routines will size the keyboard to fit the entire display. So I didn't make any size settings for the keyboard. I just let it default, and it went across the whole landscape of the display. If I did put this display in portrait mode, the keyboard will reorientate itself to fit in this direction, which is a nice feature of the widget. Other than that, I made this text box area smaller, and I made it align better with the keyboard, so that if you do put this display into portrait mode, everything's going to automatically realign itself to the new XY values. And that's the difference you see in this. So that's it for this video. In summary, we researched the 480 by 320 displays. We presented our reasons for our choice of display, and then we talked about the wiring, which is the same as the Ili9341 display. We discussed the driver considerations. We reviewed code changes I made in several old programs that we've used in the past. I found that the larger display was actually easy to interface, since it's exactly the same as Ili9341, and the software changes were straightforward and relatively easy to make. I like this larger display. I hope this video helps your LVGL MicroPython coding. Thank you for listening.